we learn about dictionary. So in Python, we have a dictionary class. Dictionary class represent a dictionary or mapping from a set of distinct key. Okay. Distinct key means there will be different. Okay. Distinct means different, or we call it unique. So if it is unique, it means for every data, it has different name or different number. And the different number or the different key will have a value. For example, GA, this is the key, and it represents one value, ID. For example, DE, it represents German. Okay. So we have another example. Let's say I want to have a small fruit. Okay, small fruit can be orange, banana. I can have another kind of fruit, which is a big fruit. A big fruit can have two kind of fruit, durian, melon. So we can represent, we call this is the key, and we call this is the value. Okay, this is the value, this is the key. So non-empty dictionary is expressed using a comma separated list of key and value. So key, and then it is separated by comma. Value. So you can see here, this is the key, and then we have the column, and this is the value. So we have the key, we have column, and the value is in the list. This is key, and then we have column, and we have value. So just remember, we have the entry key, column, and value. That's the dictionary format. Alternatively, the constructor accepts a sequence of key value pairs as parameters. It means, let's suppose I have pair like this one. And you still remember what is this square bracket? If it is a square bracket, then it is a list. It is a list, and then inside the list, I have, what is this parenthesis? It is a tuple. Okay. So inside the list, I have two tuples. Inside the tuples, I have two elements. Now, I want to make this as dictionary. How? You can just call the variable name. Just call the variable name and put it into the parameter of the dictionary. So Python implements a dictionary using almost identical approach to that of a set. Do you still remember a set? A set. Okay, we have three kind of symbol: square bracket, just parenthesis, and then the curly. Okay, curly bracket. If this symbol means list, I make it, let's see. If this symbol, it means tuple. Okay, this symbol we learn for the curly bracket, we learn about set. Set is a collection of distinct elements. So every element should be distinct. But we also use the curly bracket as dictionary. Okay. So it is almost identical approach to that of a set. So it is the same with set. The symbol is the same, but in the set we don't have any value. So we don't. So the literal form empty curly bracket, it represents empty dictionary, not empty. Now let's see. Yeah, I think you remember this is set, this is list. Now this is dictionary. Okay. That's it. So dictionary, we have a key. So the key is school and the value is vacuum. So maybe this is a kind of Hachon dictionary. I want to know what is the Korean from the English. So if it is study, the Korean is, and I can check if I want to know what is the Korean word of school. Okay. I can just call dictionary, which is this the variable name, and then I call the school using the square bracket. Then I will get the value. I want to know what is the Korean word of study. Then I will call the key, which is study, and I get the value with okay, so this is now I have what I mentioned to you in the PowerPoint. We have a list. Okay. And in the list I have two kind of tuple. So the first tuple, let's say, okay, I make another example. KR. So I want to say that KR represents Korea. Okay. Let's say I have another word, US. So US represent America. Let's say like this one. So I can make this as a dictionary. Let's say I have the Dict01. So I want to make a variable, DICT01. And this is a dictionary of pairs. It means I want to make the pair. This is the pair in this collection of tuple. There are two tuples, and each tuple has two elements. Each tuple has two elements. I want to make this one, and then I can print. It becomes a dictionary. Okay. And if I want to call the dictionary of KR, so I want to call the key, then the result will be the value of KR. And I want to know the key US. The value will be America. Okay. That's about dictionary. Now, There are many operators expression in Python. Operators mean special symbol to combine existing values into expression. The semantics of an operator depends upon the type of its operand. What does it mean? Let's say you have plus symbol. What is plus symbol? We know if it is for a number, when A and B are numbers, then A plus B indicates and if A and B are string, then plus indicate concatenation. Okay, so it depends on the data type. Yeah, it depends on the object, what you're going to do with the operator. So let's look at the operators one by one. Maybe let me show you. If I have number 2 plus 3, the result is 5. If I have string hello plus Python, then the result will be hello. Okay. It depends on the data type. Question. If I have hello plus number, what is the result? Hello, which is a string, plus number, which is 5. Then okay. Can only concatenate string, not integer to string. So we need to make this value. Okay, for the logical operators, Python supports the following keywords for Boolean values. We have 3 kinds of logical operators. First is not, and then and then or. I think it is a part of the mathematical operation. I have, let's say, p, and I have another variable q. So if p is true and q is true, okay, so we have this symbol n to represent like this, and then we have the symbol or. So p and q. So if p is 1 and q is 1, then the result is if p is 1 or p q is 1, then the result is 1. So this is represent n, and this represent 1. If p is 1 and q is 0, so 0 represent 4. 1, 0, the p and q means false. 1 or 0, p or q, it will be 1 or 2. Okay, so this is from the mathematics. If p is 0 and q is 1, p and q, it will be p or q will be 1. If 0 and 0, then it will be 0 and this one 0. Okay. What about not? Not means the negative. Not p means If P is 1, then not P is 0. So usually we can just see this kind of operation. Let's say P, I want to check whether it is 2 is greater than 3. The result of P is false. Okay. So I want to check the negation. The negation of P is it becomes 1. We need to make this as a part of the condition. So later we will do with the condition with if. Okay. So I have not checked with the if. Maybe we will do with this if later. And I have, let's say I have Q. Q is 4 is less than 5. So actually later we will do with the if. Okay. Now, if I want to put P and Q, it becomes false. 2 greater than 3, false. 4 less than 5, true. So maybe I can put here, Q is true. So P is false and Q is true. Okay. False and true, then it becomes false. P or Q, it becomes true. So this is we have the equality operators. What does it mean by equality? Equality, I want to test two notions. I want to check the left part and I want to check the right part. I want to check the left. I want to check with the right part. So there are some of equality operators. We can use is not, equivalent, and not equivalent. The expression A is B evaluates to true precisely when identifiers A and B are aliases for the same object. So this is a little bit tricky to understand this one, but I will explain it to you. And the expression A equal B. So it is more general notion. Now let's see. Okay, I will use this example. A equals 1 to 2. And then B equals 2. Now, I want to know what is A? A is a list, 1 to 2. What is B? B is also a list because B equals to B. Okay. Now, I want to check A is B. The result is true. Okay. So this variable A is the alias of variable B. Now let's check. I can use the equivalent. A equals B. The result is true because the value is the same. Okay. Now let's check another example. Let me use not A and B, but I will use C and D. So I will not use A and B. Let me just use C and D. Okay, so it's the same with the previous one. It's A and B, but I use different variable. So what is C? D is a list. 1, 2, 3. What is D? D is a list. 1, 2, 3. Okay, basically with A. Now, I want to check C is D. What is the result? True. The result is false. Why? They are the same, like A and B. A and B, they are the same. C and D, they are the same. But when I put A is B, it is true. When I put C is D, the result is false. So what is the difference? The difference is how we put the value. Okay, you can check like this. When I put B, B equals to A. But when I put D, D is a new value. That's different. So how can we check this one? We can check with the word ID. So I want to check what is the ID of A. So that's a number. This is a number in a computer memory. We do not know about it. So I can check what is the ID of B. So you will see that the ID of A and the ID of B exactly the same. It means the two variables are located in the same memory. Because I put B equals to the variable A. It means B is alias of A. Now, what about C? I have ID C. This is another number. And then when I create D, this is another number. Okay. Because C and D have different memory in the computer. That's why the result is false when I put C in D. Okay. One more time. When I define A and B, I define A at the first time. I define A at the first time, and then B equals to A. So they have the same memory number. But C and D, they have different value of memory because we define separate. Even though they have the same value, but we define two times. This one, we define one time, the other variable just equal to the first one. That's the difference. That's why when you try to see C equals to D, what is the result? It is true. Because the value of D and the value of D exactly the same. But they are not located in the same number. So I can say if you are doing with the is based on the definition, A as B, it means precisely when the identifier or the variable name A and B are aliases for the same object. So this alias means you do not need to make a new value for the variable. You just copy the variable to another variable. And this A equal B is to make a test. So to test a more general notion. Okay, please read the marking. Cannot understand the is and comparison operator. It is a natural order to distinguish between the value. I think it is common to use less than or equal to, greater than or equal to. These operators have expected behavior for numeric type on number. But later we will have some kind of example for string. For string, these operators are defined lexicographically. Do you know lexicography? It is based on the ASCII code. In the ASCII code, we already define. If you know A, B, C, okay. So this is a sequence. A comes before B. B comes before C, and so on. It is an order. So if I want to check whether A is less than B, then it's true. Because A starts first and then B. If I want to check A less than C, yeah, it is true. Case sensitivity. Case sensitive means A is different with big A. Okay. Small a is different with big. So it depends on the ASCII number. If you want to know more about the ASCII, so you can check what is ASCII. We call it, this is the American Standard Code for Information Interchange. So in this ASCII, you will see some kind of table. Yeah, you will see like this one. If capital big A, so it has a value of 55. If small a, it has a value of 97. Then, if I want to compare, A is less than A. Is it true or false? The result is false. Why? Let's see. Based on this number, big A is 65 and small a is 97. So 97 is smaller than 65. False. Okay. That's the meaning from. So you need to check with the ASCII code to see what is the value of that. It is also the same if we want to have hello compared to hello with big letter. Even though they are the same, but it is different because of the big capital. Okay. There are some arithmetic operators. I guess if you know mathematics, it is not difficult to understand this one. Plus means addition, minus subtraction, multiplication, through division, integer division, and modulo or remainder. For addition, subtraction, multiplication, if both operands have type integer, then the result is integer. If one or both operands have type float, then the result is float. Through division is always a type float. Integer division is always integer with the result truncated. Okay, what does it mean? So let's see one by one. 2 plus 3, the result is 5 because it is integer and integer. Now I have 2.0 plus 3. The result is 5.0. So one value is integer and one value is float. Then the result is float. Okay, so that's the meaning by the explanation. I can have 2.0 multiplied by 3. The result is 6.0. If one value is float, then the result will be float. If both value is integer, then the result will be integer. The same with the subtraction. 5 minus 3, it is 2. If one value is float, then the result is float, 2.2. We have two kinds of division. The first division is just one class. 5 divided by 3, this 1.6. We have 5 divided by 3. So I call this is the integer division. It means we will want to get the integer. This is the meaning by truncated. You know the word truncated. Truncated means it is deleted or it is not included. So the remaining value like this one, 0.66666, so it is not in the result. Sequence operator. Each of Python built-in sequence type. We have learned about string, we have learned about tuple, and we have learned about list. So it supports the following operator syntax. So you already know the S. Let's say now, for example, I have a list. Okay, maybe let me make a list 1, and let me make a little bit long values. For example, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So the least one is this one. So least one is a value integer value with number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and it is in the form of 3. Why it is this? Because it uses the 12 bracket. Now we want to check list 1 index 0. Index 0 means this is the starting. This is the element at the front. What about if I want to check this element? So we call this is index 0. This is index 1, index 2, index 3, index 1. Okay, then I will put list 1 index 4. So I can get the value 6. In Python, we have start and stop. What does it mean by start and stop? Start and stop means I can get the value. So this one, I want to get the value from, let's say, index 0 to index 5. Oh, sorry, this one. So I want to get from index 0 to index 5. It means index 0 is 2, index 1 is 3, index 2 is 4, index 3 is 5, index 4 is 6. If I want to check this 0 until 5, it means I will only see the index 0, 1, 2, 3, and 4. Okay. So the last index is not included. It means if you have the 0 until 5, we will see only 5 minus 1 until 5 minus 1. Let's see again. If I have list 1 from index 0 until 3, then it will show 2 and 3 and 4. It means this is the index 0, index 1, index 2. Can we change the starting index? Yes. You can change to, let's say, I want to start from index 3 until index 5. So the starting point is index 3, the next is index 4. Index 5 is not included. The last index is not included. We use only the last index minus 1. So the last index minus 1 means index 3 is index 4. Now I want to check not every single order. So in this case, I check from index 0 until 5, which is 2, 3, 4, 5, 6. But how if I have the step? Okay. Step means I want to check not every one step, but maybe for every n step. If I want to check the index 0 until index 5, for every 2 steps. For every 2 steps, then I will print 2, 4, and 6. So what about the 3 and 5? It is not, because I have these 2. These 2 means after 2 and then skip that one and then 4. So the step is 2. And then 5 is not included because we need to have 2 steps. The meaning by this 2 is every 2, well, every 2 interval. So you can also make this one as any number. Let's say I want to make 3 steps. Then it means only 2 and 5. For example, I have another list. List 2. Okay. List 2 is a negative number. Let's say -1, -2, -3, -4, and -5. I want to add list 1 with list 2. And let's say it is in the list number 3. So I can get list 3 is a collection of numbers. This is number from list 1 plus this is number from list 2. I can also make something like arithmetic with the multiplication. For example, list 1, I want to multiply with 3. So list multiply equals to, so this variable, list multiply equals to list 1 multiply by 3. Then list multiply means I will do 3 times. So this is the first value that you have. 2, 3, 4, 5, 6, 7, 8, 9, 10. And then another value appears. Another value appears. So it is duplicated for. Now I want to check, is 2 in list 1? Okay, it is, because I know there are value of 2. I want to check whether 2 is in the list 2. False, because we know that list 2 contains only negative number. We can also have not in. 2 not in list 2. Not in means it is not in the list. So it is true because we know list 2 only negative number. I want to check, let's say -5 not in list 1. It is true because the list 1 off. Okay. Okay, let me stop here. Let's have a break.